So let's have a look at some horizontal and vertical transformations. So just as a reminder, a horizontal dilation means that f of x becomes f of x on a. And for the vertical dilation, f of x becomes b times, or some constant b times f of x. And as always, you can always see the horizontal and vertical are almost like mirror images of each other. Alrighty, so where do we go from here? Well, now we need to have a think about what's going to happen to a function. So if I have a function y is equal to, let's use a different constant for our base, so let's say k to the x, well then it would become y is equal to the k x on a. Or if we were doing a vertical translation, we'd get y is equal to k to the x would become y equals b times k to the x. So those are basically the two different types of dilations we have. So let's have a look at how do we work these things out in practice. So let's try sketching this function. So this is the function y equals 4 times 3 to the x plus 2. So again, eventually we'll know how to work out the x-intercept. For the moment we're only interested in the y-intercept, which is when x equals 0. And we get y is equal to 4 times 3 to the 0 plus 2. 3 to 0 is 1, 4 times 1 is 4, plus 2 is 6. So we get our point 0.06. And then the other part we can just directly read off is the fact that we've got a 2 as our asymptote. So the asymptote does not necessarily get affected by all of this. So the asymptote, which is a super important thing, is still going to be y is equal to 2. So let's do our sketch. Oh, just have a look. Has any reflections been made? Well, no negative out the front and no negative out the front there either. So no reflections once again. So we're just dealing with a basic shape. Asymptote at 2. Basic shape means it's increasing, and the y-intercept is at 0.6. Since it's the basic shape, it's going to be increasing. And we could write some things like domain and range. So let's do the domain and range. We haven't done that for a bit. So x would be in double R. And for the range, y would be in, well, what's the smallest value of y? Well, it almost reaches this y is equal to 2 thing, but it doesn't quite. If I'm thinking about the range, right, it almost reaches there, but not quite. The smallest value is 2, but you can also see that it's increasing upwards, which means that we are going to get up to infinity. Now, infinity, we always use a smooth bracket, but for the 2, because it's an asymptote, we do not include it, so we do use the in-inclusive. If I was doing this in alternative notation, I'd say that y has to be bigger than 2, but less than infinity, or just that y is bigger than 2. Either option would be perfectly fine. Alrighty, let's look at one more and then we'll move on. Alrighty, so for this function we're going to get the y-intercept is when x equals 0. We get y is equal to negative 6, 3 times 0 plus 1. So it's negative 6 to the 0, which is negative 1 plus 1. And so we get an intercept at 0. Cool, haven't had that before. So we've got 0, 0. In fact, we now know an x, our first x-intercept we've worked out so far, because it just happens to be a y-intercept. Our asymptote is going to be 1. And now we can sketch. And you can see there is a negative there, so we do have to be careful because it has been reflected, and we just have to have a think about what sort of reflection it's been. So the asymptote is at 1. And the y-intercept is at 0, 0. And we've got y equals 1. Alrighty, so there's our 2 pieces of information we've worked out so far. Now, obviously it can't be this shape where it goes above the asymptote for the reasons that if it goes above the asymptote, it's definitely not going to hit the thing. So it has to have reflected in the x-axis. So if it reflected in the x-axis, it could look like this, or the other option is that it could look like this. Both of those options would be perfectly fine. Yeah? So the question is, how do we work it out? Well, only one reflection has been made. One is negative, the other is positive. So we haven't done double reflection. So since this is our original shape, there's only one of those two options that work. It can only be this shape, it cannot be this shape. And if we go back to our rules, we'll remember that that's our double reflected one. So in this case, the only way it could be is to start at the asymptote and then go away. It's been reflected just in the x-axis. Now, if you couldn't work that out for yourself, how else could we do this? Well, subbing in a few points would be probably the easiest thing to do. Just subbing in a couple of x values and seeing some extra points, and that will give you enough guidance as to how to sketch the rest of it. Alrighty, so there's sketching with horizontal dilations and vertical dilations. See you in the next one. Goodbye.